Let's go ahead and get started. I'm Kelly Hill, editor for Test and Measurement with RCR Wireless News, and I'm hosting our webinar today as we talk about transitioning to 5G, and in particular, the implications that is going to have for test. RCR Wireless News is the premier news source for the telecommunications industry, and we're glad that you were able to join us today. Make sure you check out the latest news on rcrwireless.com. Your panelists for today, I'll be your moderator. I'm editor for Test and Measurement at RCR Wireless News. Unfortunately, Hank Kafka was not able to join us at the last minute, but we do have our other panelists who include Jesse Cavazos, who's industry director for Test and Measurement for the Test and Measurement practice at Frost & Sullivan. And then we have Yvonne Rualt, who is technical advisor in the CTO office for Expo, and George Hurtarte, who is product manager with Lightpoint. So all of those folks to give us perspective today. Just a few key takeaways from the special report that I've been working on, and that's going to be available as a free download on rcrwireless.com today. The industry is moving rapidly toward 5G. The first specification is expected next month. That's going to be primarily physical layer focused, and then we should have a protocol release early in 2018. There are a number of features and architectures in LTE, particularly gigabit LTE, that will both underpin future 5G networks and provide lessons learned for making 5G systems work. Some of those things, MIMO, particularly higher order massive MIMO leading into massive MIMO, virtualization, and a number of other architecture features, including densification. The biggest challenge for 5G lies in a millimeter wave RAN. There's a number of challenges in terms of both propagation and in terms of the fiber requirements for that. That generally, when I talk to folks, that was their conclusion, that's really the tough part. And then testing equipment is expected to become more modular, more flexible to enable testing of both advanced LTE features and the beginning of 5G. So with that, I'm going to hand it over to Jesse Cavazos of Frost & Sullivan. Jesse?
Hi, Kelly. Can you hear me?
Yes, we can.
All right. Well, hi, everyone. Thank you for your time this morning. In my few minutes, I'm going to try to paint an overall picture of adoption issues and challenges associated with the development and deployment of 5G networks. This is based on research that our team has performed recently. Can you move on to the next slide, Katie? All right. Overall, we expect 5G to have a profound impact on industries such as healthcare, automotive, industrial, and telecom. The use cases will be critical to justify 5G trials and expedite network deployments. Key use cases include fixed wireless access, IoT, and improved throughputs or enhanced broadband. There will be corollary use cases enabled by the primary use cases, such as smart cities, smart infrastructure, and enhanced connected living concepts. While robust connectivity is a prerequisite, cybersecurity protection will play a key role in 5G deployments. A collaborative approach for faster deployment of 5G networks is being advocated at the industry level. While vendors and carriers are working on monetizing strategies, support from regulatory bodies will offer clear instances for proactiveness from industry participants. Next slide, please. So from a network perspective, we can see there's different topologies that are being tested. Most trials are at 28 gigahertz, with others at 3.4 to 4.2 gigahertz. However, most of the radio bandwidth available for 5G will be at very high frequencies. Frost & Sullivan believes that 5G will be a heterogeneous network using a wide array of spectrum bands and radio technologies. The network will be overlaid with ultra-dense access networks, and we expect macro networks to be upgraded using more antennas and techniques like beamforming, for example. Although there are two paths to 5G, enhancing LTE is the starting point moving to 5G either way. With 3GPP, LTE Advanced Pro is a marker of releases 13 and 14, and emphasis on 5G is placed in release 14 with work on the new radio access technology. Release 15 includes the first 5G specifications, and release 16 aims to meet IMT 2020 requirements. In terms of regulations, the FCC is taking measures to support 5G services. It is reviewing the legal framework for infrastructure deployment to remove regulatory barriers, and it's also making relevant spectrum available for operators and has started the process to make additional unlicensed mid-band and millimeter wave spectrum available for 5G. Next slide, please. 5G and fractional versions of the standards are expected to boost the test and measurement market in the short, the medium, and the long term. Commercial wireless communications have been under 6 gigahertz. The drastic changes in frequency and modulation bandwidth require upgraded instruments. Currently, participants are trying to build IP that will be part of a standard. That's generating a lot of growth for test and measurement vendors. There is a significant pressure on reducing development time, which is driving engineers to leverage modular instrumentation to avoid developing hardware. Over the next couple of years, 5G will progress along the life cycle to development. Development is really when 5G truly starts generating significant revenue for test and measurement. This should happen around 2019 when a more defined standard is in place. From then on, opportunities for test and measurement will pick up in conformance and acceptance testing. While smartphones already undergo thousands of tests for general certifications and specific carrier test plans, this will increase with 5G. Over time, carriers have outsourced more and more to specialized test houses, and we expect this to continue due to exponential growth in the size and complexity of the test process, competitive pressure, and also the growing cost of test. The test and measurement market will then witness a wave of demand from manufacturing that will translate into significant growth for a couple of years. While participants do not always wait for the standard to be finalized to move forward, and this is definitely the case with 5G, the cellular testing market typically really takes off once that occurs. With technologies requiring higher instrument performance, one of the major challenges ahead is the cost of test. This is likely to lead to a shift to more cost-effective solutions and new business models. Also, suppliers must devise strategies to address different frequencies at the same time, as customers will have different products. They have to come up with a solution or solutions to address all of these frequencies, while in the past it was a single option. We also foresee more OTA, over-the-air testing, as it becomes more difficult to connect test equipment to different parts of the DUT. The greater integration of devices will also likely lead to changes in test strategies. So we expect module suppliers to become increasingly responsible for tests. Certainly, the years ahead are going to be excited from a test perspective, and it requires some significant thinking from test and measurement vendors. That's Kaylee on my end.
Okay, great. Well, those were Hank's slides. It's worth noting that I interviewed him recently, and he talked to me a little bit about some of the some of the testing that AT&T has done, which I thought was really interesting in that they looked both at sort of long-term seasonal testing, as well as they developed an instrument called the Porcupine with National Instruments in order to get sort of a microscopic view, more or less, of what was going on in the 5G channel at millimeter wave. So it was some really interesting stuff. Unfortunately, he wasn't able to join us. So Yvonne, if you could go ahead and walk us through your slides. Folks, if you have questions for any of our presenters or questions about the topic in general, please use the user interface, submit those. Once we're through all of the slides, then we'll jump into discussion.
Thank you, Kelly. Thank you, Kelly, and good morning or good afternoon, everybody. Yes, I am Yvon Roux, based in Paris, actually part of the CTO office group of Expo, and I'm in charge of the mobile networks. So next slide, please. So what I'm going to talk about is the impact of 5G on the test and measurement as a whole, and in particular what Expo is focusing on. So there's definitely an excitement with 5G right now. But 5G is still, like Jesse said, in the crystallization phase. That's my term, but what it means is lots of components of the 5G are not really standardized yet or fully standardized yet. If I mention the network slicing, for example, 3GPP is working on it, but there is no release mentioning it clearly yet. But the same for the front haul, for example, with the new functional split being discussed at the IEEE, but also standardized as 3GPP. And some options will become available soon by December normally as part of a pre-release 15 standard. But this is fundamentally required for the virtualization of the BBUs, for example. Same for the mobile edge computing, very key for the enhanced mobile broadband. But at the same time, Etsy is working on it, but there is not the works are not finalized yet. And generally speaking, 5G will require a lot of virtualization of the core network. But all the consortiums involved in the NFV SDN platforms like ONAP, Open Source MIMO, and others, they are still actively working on it, developing millions of lines of code. But the full closed loop automation is not really there yet, and this is key for the network slicing. So 5G. I mean, apart from the fixed wireless access, what was mentioned as well by Jesse, and by TNT, there is still a gap basically between now and 2020 or 2022, 3, 4, 5, until we have a real 5G network out there. But that's not really a problem, because operators believe that there is still a large latitude to upgrade their existing 4G LTE network to address most of the 5G verticals. And 4G, by the way, is a real component of the 5G story. I mean, the release 15 and 16 will include 4G LTE RAN. I mean, it's not a legacy network. It's part of the story. So with 5G, the complexity of the network will move to the edge, obviously, and I like this analogy, but basically the radio map will look like a spotty map. There will be lots of different technologies coexisting, but what is common really here is, and what the operators really have to do between now and 2020 is really to deploy top-class fiber network, because there will be fibers everywhere. They have to adopt a centralized RAN architecture or cloud RAN architecture for some of them, and they have to build a hierarchy of data centers with local, regional, and central data centers, and not only the data centers, but the interconnectivity between the data centers. In the short term, we will see the fixed wireless access, but this is a very specific use case, and this is not necessarily well. It will generate challenges for sure, but it's not necessarily representative of the all 5G challenges here. Next slide, please, Kelly. Okay. No, yeah, that one. Thank you. So there are challenges, but there are opportunities as well. In particular, opportunities of lowering the costs of operation, of deployment, increasing the efficiency, the reliability, and the quality of the network. And each of the components here are contributing to that. For example, the adoption of CRAN and Cloud RAN will provide more flexibility, better efficiency, etc. But at the same time, we will see an increase or an explosion actually of the bit rate on the front haul and the back haul, and with a significant distance between the cloud or the CRAN hotel and the cell sites. And in particular, with the enhanced mobile broadband, this very high bit rate will generate new issues. For example, it's very known in the fiber optic domain, but above 10 gigabit per second, it is very well known that there are some optical dispersion issues, for example. Okay, that's very new for the mobile industry. And same with the CPRI. I mean, there will be a transition from, for the front haul, there will be a transition from the CPRI transport mechanism to an Ethernet transport, which will again generate new test methods, new constraints, new issues, and requiring new skills. So basically, the densification of the cells, in particular due to the increase of the frequencies in 5G, will make the RF interferences the #1 problem. Okay, for the RAN engineering teams. And hunting RF interferences, finding the root cause, will require more automation, centrally located, let's say, expertise and technicians and engineers, and basically, it's very key for operators. They want to limit the very costly truck rolls. And finally, the network slicing itself is based on NFV. So again, we have some ideas of what it will be, but fundamentally it will be based on a lot of parallel virtual networks, in particular in the mobile core. So the operation of them, the upgrade of them, basically everything related to those slices will need to adopt the IT methodologies. Process automation, DevOps for upgrading or bug fixing. And that is new as well from a network operation perspective, and also from a network testing perspective.
Great.
Last slide, please, Kelly. Yeah, thank you. So just a few words on X4, if you don't know X4 that well. So X4 started in the optical test domain more than 30 years ago. So, of course, obviously, we have significant expertise in testing optical networks, which makes a lot of sense when it comes to 5G, because 5G basically will have fibers everywhere. It's fibers between the data centers, it's fibers between the cloud RAN and the cell sites, and on the cell site itself, it will be fibers again. So basically, X4 started with optical fibers, but in the meantime, we also developed expertise in other domains, which are also relevant in 5G. For example, the high-speed Ethernet with 10 gig, 400G happening now as well, and we can expect some of them becoming relevant for the backhaul, for example, but definitely as well for inter-data center communication. In the cloud as well. So, like I said, X4 developed some methodologies and test tools for the data centers in intra-connection testing, but also inter-data center connection testing, very, very important at very high speed. IoT and NFV are very key as well, as I mentioned before. And here, X4 has a business unit in charge of the lab testing. So in the lab, we can simulate millions of IoT devices. We can simulate a virtual core network if you want. So basically, we can simulate what doesn't exist for carrying the test. And last but not least, service assurance will play a more and more important role in the 5G because of the virtualization of the core, because of the slicing of the core, and that will generate will require automation, and automation means basically service assurance to feed the closed loop automation mechanism, and this is a place where X4 is involved as well.
Great. Great. Well, with that, folks, if you have questions for Yvonne, please submit those through the interface. Now we're going to move on to George Hurtarte of Lightpoint.
Yes, hello everyone. Can you hear me, Kelly?
Yes, we can.
Okay, fantastic. Fantastic. Thank you. Yeah, this is George Hurtarte. I am with Lightpoint and the product manager for the 5G products. And Lightpoint is a leader in providing test equipment for the RF industry. And obviously we are working deeply into the 5G trends, as outlined by Jesse early on. So one of the challenges that Jesse talked about and also was touching the presentations is the fact that we have new, and this is new millimeter wave and sub-6 gigahertz spectrum with higher bandwidth. So millimeter wave frequencies are exactly that the wavelength of the radio waves are in the millimeter type of range. So what you see here is on top, it's a bunch of bars, and on the bottom it says FCC in blue. So what's this? So if you look at the FCC, the Federal Communications Commission in the United States, they have already approved the bands in blue as of July 2016. So that means that the US government has authorized the use of the frequency bands in the 27.5 to 28.35 gigahertz. This is in gigahertz. So again, when you're in the gigahertz range, you're talking millimeter wave. And also you see another band between 37.37 gigahertz to 38.6 and so on and so forth. So those two are commonly known as the 28 gigahertz and the 39 gigahertz millimeter wave bands. On the right, you see 64 to 71, that is unlicensed spectrum, unlicensed. So primarily used for connectivity applications, like you probably heard 802.11ad, AY, and so on and so forth. So on the top, you see several red bands that are still being considered by the ITU. And the ITU will be working with the WRC, which is the wireless consortium of frequency or spectrum standardization in the world. And we expect that by 2019, we may see other bands. So one of the key challenges for test equipment is the ability to support multiple bands as they are being released or approved or standardized all over the world. And as you can see, these particular frequency bands also include a spectrum bandwidth in excess of 100 megahertz. So for example, 28 gigahertz band by the FCC, it's about 800 megahertz. And this is another challenge in terms of test equipment. Why? Because currently and historically, test equipment supports more like 50, 100, 160 megahertz bandwidth. At the bottom of this chart shows you the frequencies below 6 gigahertz that are being considered across the world for 5G. They are called the C bands. And as indicated earlier, they are in the range of 3.5 gigahertz and 4.5 gigahertz. So basically between 3.1 and 4.2 gigahertz in different locations. What's important about these new frequency bands at sub-6 gigahertz is that the bandwidth will also be expected to be greater. So today, for example, 10, 20 megahertz or carrier aggregation up to 100 megahertz is pretty much the LTE standard. But with a bandwidth in the range of 100 to 200 megahertz, we'll see more data rate being available through these frequency bands and bandwidth. So summary, new bands, multiple bands, test equipment needs to very quickly support new bands are being released. That's a new challenge for the test industry. Next chart. Also, the other challenge is the fact that millimeter wave frequencies, there is a capability of the devices to have multiple antennas. So if you imagine an antenna that is 2 millimeters on the side, 2 to 2.5, 3 millimeters, that sort of range, that's very, very small antenna. So by having multiple antennas in a module, for let's say 16, 32, 64 antennas, then you have multiple antennas that can be directed, as you can see in the bottom graph, the bottom chart. And the energy of the antenna beam can be directed towards the user equipment, let's say the smartphone. So the little progression that you see in the bottom here is an antenna array that is searching, so to speak, for the smartphone, and you can direct the beam or the energy of the antenna towards the specific user. This is a new technology called beamforming, And it requires that the test equipment be able to characterize how these antennas perform. So there are multiple antenna paths, and because there are multiple antenna paths, they need to be characterized. Now, this means that radiated test is key for this type of technology. This is called over-the-air testing. And over-the-air testing basically means that there is no contact to the device under test. It is all radiated. So that would require that the device under test be put inside an OTA chamber, like the one shown in the picture. And this requires that the chamber has a mechanisms to physically move the dot in different directions, different axes, to test the beam antenna, beam forming or the antenna, and the ability to have a massive number of multiple inputs, multiple outputs, what's called massive MIMO in dot, being able to characterize it. So radiated test rather than contacted test is a key challenge for millimeter wave, and obviously Lightpoint is in the forefront of this technology. Next slide. The next one has to do with something called EVM, the error vector magnitude measurement. This is a measurement of the error of the ideal location of a point in the constellation of the I and Q, and these are electrical engineering terms and radio frequency, the I and Q axis, where there is an expected point in the X and Y or Q and I constellation of a point that carries data. And if that point is not exactly where it needs to be, then there is an error. And the error has to be a minimum tolerable error for the channel and the device to be able to perform. So measuring that error at millimeter wave frequencies with higher bandwidth is a key challenge expected for 5G millimeter wave. So test equipment needs to be ready to perform and measure these EVM numbers when you have 64 points in the constellation, even up to 256. And as you can see, over the years, the progression has been from just 2 on the left, 4, 8, 16, all the way to 64, 256. So EVM is a key test requirement that 5G test equipment needs to be ready to measure. So in summary, multiple bands, a millimeter wave and sub-6 gigahertz, over-the-air testing, radiated test, beamforming, massive MIMO, and EVM are key requirements that test equipment needs to support. And at Lightpoint, we are working on this, and we are very deeply involved in the 5G deployment. Thank you.
Okay, great. Well, thank you, George. We appreciate that. So we are starting to get some questions in from the audience. One that just came in is, can you tell us what bandwidth 5G will work with? Now, if I remember correctly, I believe the folks that I talked to said up to 2 gigahertz. But George, I know that you had talked about the bandwidth as well as the frequency challenges.
Yes, correct. So, depends on the bands, right? So if you look at 28 gigahertz, that's more in the 1 gigahertz bandwidth range. If you look at the unlicensed spectrum in the 60 to 71, that is already 2 gigahertz. And there is also work being done in the IEEE to increase this even higher.
Okay. And then, Ivan, we did have a question for you about your presentation. That after your presentation, it looks to me like we will only have 5G in 2021 to 2025, right? Everything before is LTE Pro. I think technically, I mean, we won't have, if I remember correctly, the 5G timeline is that the official, I mean, we'll start getting the 3GPP specs, hopefully next month, start, and then into 2018. So we'll start having 5G NR at least available, and then, but as far as finalization from ITU, I don't think that's scheduled until 2020 still.
From ITU, you're right, probably. The fundamental dates are in December. Normally, yes, 3GPP will release a partial release 15, which will cover only the RAN, so what you call the 5G NR for the new RAN. That's true. And it will include, for instance, 2 or 3 different options for the functional split on the front haul. Basically enabling higher speed front haul, basically, in particular for fixed wireless access. So it was a big push from the AT&T and the Verizons who wants to have the fixed wireless access standardized. But the release 15 itself will be out in June 2018. So in basically 6 months later. But that one will be what we call the non-standalone 5G. So it means the coexistence of 4G RAN and 5G RAN serving a 5G core or a 4G core. So basically, all combinations will be possible here. So what we can say that the initial phase here, release 15 in particular, is very much a RAN focus rather than a full end-to-end 5G network focus.
Kelly, this is Jessie here. I think what we're seeing as well is that, you know, what is your definition of 5G? When we came to 4G, you know, we had people are talking about 5G deployments. If you're defining 5G as it is defined in the standard with the final targets going at, you know, the millimeter wave and so forth. So when will that actually be deployed is certainly far from now. But if you're talking about, you know, maybe parts of the technology being deployed and so forth, then it changes the timeline quite a bit. So I think we'll have to be in that, I don't know how to, you know, fog for a little while as far as when people ask for timeline on 5G. Really depends on your definition.
Yes, and it depends on your marketing team if you're a carrier. You know, and I think we saw this, you know, in the transition from 3G to 4G is that, you know, when you looked at the standards and the speeds that were set for, you know, for quote unquote 4G, you know, LTE didn't actually get to them, and I think until LTE advanced, really. But LTE, even in its very early iterations, you know, was called 4G. You know, regardless of what the standards bodies were specifying in terms of speed. So, you know, the marketing and the actual generation are always a little bit out of step. It seems.
Yeah.
Okay. Great. Did anybody else have anything to add on that? Otherwise, we'll move on.
Eventually, just one sentence. It depends very much on the use cases. 5G will become real when there will be new use cases that doesn't exist today and cannot be addressed with 4.9 or 4.5G, whatever you call it. And from this point of view, fixed wireless access is 5G. So basically, that would be the beginning of an official 5G network.
Okay. So here's an interesting question. And George, this gets into some of what you said. You know, will beams be steered in sub-6 gigahertz 5G? Also, how do you test the beams over the air if you need a UE or test mobile to lock onto the beam? Now, I think that's a really interesting question in terms of will beams be steered in sub-6 gigahertz 5G in terms of, you know, are we really going to get into massive MIMO when you're talking sub-6 gigahertz? And what I've sort of gathered from the industry is that, you know, if you're talking about 600 megahertz, probably not, just because of the antenna sizes. If you're talking about, you know, 2.5 or 2.4, you know, maybe, probably.
Yeah, it's a good question, excellent question. And I think we need to divide the question into what part of the network we're talking. If we're talking about the base station, you know, that is up in the poles on the street, on the highway, then there is definitely more physical size to put multiple antennas, right? As compared to a smartphone or a CPE, central premises equipment, and so on and so forth. So, you know, it's a function of the physical size available on that particular device. So definitely at base stations, you can be thinking of multiple antennas, you know, beyond what we have today. 8, 16, 64 even. And there is announcements by key network providers saying massive MIMO 64 antennas at sub-6 gigahertz. But that's a base station. definitely it would be very difficult to do that, obviously, on a smartphone because of the size of the antenna.
Okay. Great. Well, Jesse, I wanted to ask you if you can talk sort of, sort of broadly and give us some sense of what some of the challenges are for the industry, for the test industry specifically, when it comes to millimeter wave, because we just talked a little bit about sub 6, but a lot of the conversation really is focusing in those millimeter wave bands. And so your thoughts on how that's going to impact the test industry. Jesse, I think you might be muted.
No, it's better if I unmute myself, right? Yeah, I was trying not to disrupt the conversation, so I went on mute. But yeah, millimeter wave is really a hot topic to discuss in the industry, and when it comes to 5G, this really has the test and measurement, vendors. I think from a technological perspective, radio access technologies and the ability of these frequencies to propagate through materials. There's also, in terms of challenges for millimeter wave, there's the use of directional antennas that's required for due to path loss that's coming from the increasing frequency combined with maintaining the antenna wavelength. And I mean, that's really from a high level view, but there's also, channel dynamics and interference issues to address. And certainly phase noise is more important in higher frequency bands as well. That's really a high level view, but that's what we're looking at in terms of the challenges for millimeter wave when it comes to testing.
George, do you want to weigh in on that? I know that you guys, if I remember correctly, you guys have a solution for WiGig testing, and so you've probably already sort of been exploring this a little bit.
So the challenges for millimeter wave are related to the ability of the test equipment to support the different bands as they are, let's say, standardized. So 28 gigahertz now and 39 gigahertz now. So test equipment needs to remain flexible and quickly respond to new bands being adopted. So obviously the ideal situation will be one box supports all bands. But as the market is still uncertain as to what bands will be approved in the 2019-2020 timeframe, this needs to be an ongoing monitoring of the market. And of course, the bandwidth is the other situation there. So the combination of quickly adopting to new bandwidth, new bands and new bandwidth, the ability to support beamforming over-the-air testing, and the ability to be able to measure the EVM numbers and multiple points constellation on 64, even 256. Those are the key requirements that test equipment needs to be supporting.
Okay. Yvonne, I'm wondering if you can weigh in here a little bit in terms of some of the challenges of millimeter wave, because when you and I talked, had our conversation for that I was able to include some of in the report, you talked a lot about deployment challenges, and some of that goes hand in hand with the propagation characteristics of millimeter wave. And I believe when I talked to Mike Murphy, who's CTO for Nokia North America, he mentioned that operators should be preparing to do, and it was something crazy like 2.5 to 10x density of sites than what they have now. And the industry, frankly, has had a lot of difficulty even in ramping up small cell deployment for LTE in spectrum that doesn't have some of these propagation challenges. So I'm curious as to what your thoughts are in terms of the challenges on the deployment side of millimeter wave.
Yeah, so I will leave the RF issues to the RF experts, because X4 is not touching the RF itself, but we are touching definitely the deployment of the cells, the antennas, and everything. and backwards to the core network as well. So yeah, definitely, you're totally right. I mean, it's been a concern already in 4G somehow. You know, the use of or the subcontracting of the deployment to low-skilled, or let's say non-expert people to cut the cost down. But now it's not just a matter of cost here, it's a matter of dimension. You know, like you said, I mean, we could expect 10 times more antennas for some technologies to be deployed. And that is a real issue. The way I think that this will be addressed is by minimizing the test that must be done during the rollout itself on site. But instead increasing the test being done from the CRAN or Cloud RAN sites, right? So basically remote testing through the front haul to the antennas, to the RU or RH, whatever you call it. So there will be an increase of that. And already today, I mean, we are developing solutions to go to that direction, in particular to do a lot of tests, like optical tests, to characterize the fibers and the quality of the fibers, and not just the fiber itself, but the connectors and everything, collecting the data from the RH or from the SFPs and everything, but also, for instance, measuring the RF interferences remotely. So these kind of things are happening now and will be very much developed in the future. But there is one last point, if I may, that I believe in, is that due to the complexity of the technologies, because from an RF perspective, you mentioned the massive MIMO, beamforming, etc., but also from the optical domain, but also from the RF domain, and not the RF, sorry, the bit rate and Ethernet will come in the picture as well for the front haul in the future. So we cannot expect these people to be competent in every aspect. So I believe that, and this is something we are working on right now, is to make very, very simple to use probes or portable equipment that they can use, you know, but more to collect data rather than to perform tests and interpret the result and act, you know, upon the results. Instead, you know, it's more like collecting the data. The data are fed back to a central point where the subject matter experts can really do the job. This is more the way, and ultimately we're starting thinking about adding some artificial intelligence in there, because you know, interpreting the curves and the results automatically to come with some diagnostics or additional questions automatically. The automation will be very key.
Okay, great. Another audience question was, do you see coexistence of spectrum use, i.e. the same band for both LTE and 5G at the same time? Now, I know in the context of gigabit LTE, we're talking about the aggregation of, using LTE and unlicensed spectrum. I don't know if we've necessarily gotten to the point of discussing 5G in unlicensed spectrum. George, I don't know if you can sort of weigh in on, thoughts on the spectrum side of this, since that was something that you touched on in your presentation. Certainly there seems to be, a number of bands, but we see a number of bands in LTE as well, 40 plus, I think.
Mm-hmm.
At this point.
Yeah, so for example, let me give you an example, 3.5 gigahertz CBRS band in the United States. That is a shared spectrum. By shared, which means it has 3 tiers. Tier number 1 is the current incumbents, basically the ones are using satellite or, the Coast Guard, for example, users of this existing spectrum. Now, the FCC has recently opened up the same 3.5 gigahertz CBRS band as a layer 2 for cellular providers, the typical, providers here in the United States, the mobile network operators, to utilize that spectrums in chunks of 10 megahertz up to 70 megahertz of bandwidth for available for the mobile network operators. That's licensed. And then there is tier 3 in the layer, which is unlicensed.
Yes.
That's about, if I recall correctly, it's about 80 megahertz. So one can conceive that this spectrum can be used for 5G, quote-unquote 5G, as Jesse pointed out, there's many definitions. But, and then being able to utilize the unlicensed layer, okay? And then offload pretty much what's being done now by the LAA, meaning license assisted access at the 5 to 6 gigahertz unlicensed spectrum. So I think we will see a combination of using licensed and unlicensed, and you're still out whether or not that will happen at millimeter wave as well. It's already happening at 5 to 6 gigahertz, share, and the 3.5 share spectrum is expected to do the same. Okay.
Great. If I could get all of you guys to weigh in on this next one, and that is, what do you think the area will be of most challenge for 5G testing? We've got R&D, which is still going on, and still, as folks try to figure out more about channel behavior and propagation, and also try to shape the standards that are, that won't just end next year. They'll, like LTE, they'll keep developing. Then we have field testing. It was sort of interesting to talk to folks like Samsung for this report and hear about, field testing these things, these early, 5G fixed wireless implementations is a real challenge. And then, there's the manufacturing context, which, sounds like it is going to be a major challenge in terms of, what does this mean for production lines? What does this mean for costs? Particularly when you start thinking about, and again, that's very much in the millimeter wave context. So I don't know if there's anybody who wants to start off on that. Jesse, maybe we can start with, with your thoughts on that.
Yeah, I think what's interesting is on this panel tonight, you have two very different perspectives, one from, Expo and one from more of a manufacturing focus with Lightpoint. So I think when you talk about 5G, which area is going to be the most challenges depend on who you ask, for them. And you actually said field testing and commenting on Samsung. I tend to associate field testing with installation, deployment, so more of a carrier as opposed to, but there is certainly, a lot of field testing happening for devices before they get accepted to be deployed, to be able to be accepted by different carriers and so forth. So for me, I've been doing a lot of research. I think it's manufacturing. Certainly, research is challenges. You have, the greater complexity of 5G technologies. It's just not one step up from 5G. The 5G targets, they really often exceed 5G by a large margin. We're talking data rates of 100 megabits per second average versus 25 megabits per second for 4G. In peak data rate, and then we're looking at 10,000 megabits per second for 5G versus 150 megabits for 4G. So and the other one also that is quite challenging is the latency target that's under 1 second for 5G, when right now it's about 50 microseconds for 4G. So I think you also have, mobility, density targets that are just multiple times that of 5G. I think the reason I would pick manufacturing is because there's a significant challenge to overcome for the industry when with the cost of test. I'm sure deployment certainly won't be easy, but I feel that manufacturing challenge has to be solved first before you move on to deployment, basically.
Okay. George, your thoughts on what area is going to be the most challenging?
Yes. So going back to millimeter wave, this is a 10x disruption in the market. The industry has been working sub-6 gigahertz for the past 30 years. So our RF engineers in R&D and design verification have been spending the last 2 years in this learning curve. Absolutely. When it comes to manufacturing, the test people on the floor, the test engineers, they really need simple, easy to use, cost-effective, high-performance test solutions for manufacturing. So the pragmatic approach that Lightpoint has been taking is the fact that we can deploy a box test equipment for millimeter wave in the R&D lab that's easy to bring into design verification and has a path to manufacturing with a very easy interface. You know, having multiple bands, having multiple frequencies and bandwidth, we cannot give the manufacturing people 20, 30, 50 buttons to configure. It has to be a very straightforward software interface, very few buttons, very few connectors, is ready to go very cost effectively. So R&D to DVT to manufacturing, that path needs to be very smooth, very transparent, and that is the only way that is going to hit high volume in the 2019-2020.
Okay. Ivan, your thoughts on, you know, from Exvo's perspective on what area you see as the most challenging for 5G testing?
Yeah, and I will make JC right once again. I mean, definitely a different perspective for me. So maybe manufacturing is a concern. I mean, I'm not an expert in that, so I will not challenge this, but fundamentally, again, I mean, the multiplication of the number of sites, also the access to the sites, you know, more and more antennas at the top of the poles and the lamp poles and so on. So this will make just the deployment, first of all, the maintenance, the support, the operation, very difficult, very challenging. Also, again, I mean, operators have a lot of issues of reducing the cost of operation. So they don't want to go on site anymore. So, but that generates a challenge, and this is where the challenge is, because if you want to monitor, if you wanted to get access to all the necessary parameters remotely from a central location, you need to have access to the monitoring points. I mean, and that remembers me very much what happened at the beginning of the 3G when you know, we removed the IUB interface. And basically, there was no access anymore. 4G, sorry, there was no access anymore to some KPIs coming from the handsets, and basically the 3GPP and the ETSI, they standardized what we call the minimization of drive testing. It's 3GPP standard for that. Very much similarly, I mean, if we move to the new functional split and so on, there will be no access to the RF information, digital RF information in particular, in the central point, because this will exist only on the sites. And I'm dreaming of a kind of a new standardization as well for this, what I could call, for instance, the minimization of truck roll methodology, and that is a challenge. I mean, to be able remotely to get access to the RF interference, to the PIM information, to detect them, understand them, and fix them remotely. That will be a major challenge for operators.
Okay. Great. Well, for our last question, and I apologize, everyone, you guys had some excellent and very technical questions. I'm going to ask our presenters where appropriate to follow up with you afterwards and get those answered. But for our panel, for our final question, you know, one of the things that I keep hearing over and over is that, you know, there are some fundamental things about 5G that 5G testing, excuse me, that will need to change in order to make 5G, just to make it economically makes sense in terms of the numbers, in terms of scale, in terms of cost of materials, in terms of you know, how folks approach testing. So what I want to ask you is, you know, do you think that, you know, given the high cost of entry to the testing market, the technology demands of 5G, you know, do you think it's possible to disrupt the 5G testing market, or you know, what might be some potential areas for disruption as we move into this new generation of technology? So Jesse, I'm going to go ahead and start with you.
Absolutely. I think, you know, with such significant changes, and there's always potential for disruption. We can see the technical demands are high, but it's especially the case in research. What is tested in manufacturing is only a subset of what is done in R&D, so the technological barrier somewhat decreases. And the cost challenge in manufacturing, I think, is so important that it does drive interest with new approaches and new solutions. So even in research, I mean, there's been changes with there's such increased pressure on reducing development time. Speed is really critical in research now because they want to get the first to get somewhere. A lot of people are leveraging modular instruments to get there because they don't want to develop hardware. Also, there's the service play. During my few minutes earlier, I spoke about conformance and acceptance tests. Because of this exponential growth with complexity, with competitive pressure and growing cost issues, there's really a play for test houses, for example, that have invested millions of dollars in test equipment and personnel that have significant test expertise and as well as expertise in the technologies as well. So I think, yeah.
Okay, great.
Yeah, that's it. I think that's made my point.
Yeah. All right. Well, Yvonne, your thoughts on potential disruption as we move into 5G for testing?
Yeah, well, first of all, we must believe in a permanent disruption. I mean, that's the nature of technology in general. But then also we must follow the pace of innovation of what our customers are using. For instance, moving to 5G, we must innovate in that domain for sure. I would take an analogy of what happened in the past, and just to explain what I foresee in the future. A few years back, to test or to fix a problem or to discover a problem on an optical fiber, it took really almost a PhD in optics to understand this OTDR curves, and how to interpret that and how to discover out of it that there is a splice somewhere, there is a reflection somewhere, and understand that. That is not necessary anymore. Now, just a regular technician, even myself, I can just take an OTDR and use a special software on top of it that will interpret the curve for me. Okay, and we'll just highlight the problems and actually identify the cause of the problem immediately. So there is no need of expertise anymore. The same thing will continue to evolve for sure. And when it comes to 5G networks, that can be extended to everything we can measure. It could be the interferences, the spectrum analysis for the baseband, for anything. Basically, we can expect that, and even further. Personally, I believe in, like I mentioned before, but I believe in artificial intelligence to interpret those curves and those results more intelligently, let's say, by having a software that can grow its knowledge base and that can become more and more efficient and more specific on a per operator basis, understanding the topology of the network of the operator and so on. And this is where I think that the future will go, and it may come sooner than we expect.
Okay, all right. Well, AI will be doing our testing for us. George, your thoughts on disruption or the potential for disruption when it comes to 5G testing?
Yes, two thoughts on that. Obviously, the technology is moving from contacted to radiated type of testing in the case of millimeter wave, not so much in the case of sub-6 gigahertz. So we had to divide the question in two segments, right? Sub-6 gigahertz and millimeter wave. Okay. So the key challenges for millimeter wave do provide a disruptive challenge opportunity for the test industry. And I'm going to mention two. One is, as just pointed out, we need to bring simplicity to the test and the manufacturing environment. We cannot ask an operator or a test engineer to worry about 100 buttons and switches to configure and calibrate. Simplicity is important. They just want to run, go, and test, and do it very quickly. Throughput is a key, so to speak, because that impacts cost of test. And second is, if indeed radiated tests via OTA, over-the-air tests, becomes a requirement in high-volume production for millimeter wave, that is disruptive. Because then, will you need test chambers in production? How big will they be? How much space it will take? Or maybe they will not be there. So that's a question yet to be defined. But if that becomes a requirement, that is indeed disruptive.
Okay. Great. Well, thank you, all of you. Thanks to all of you for giving us your time and perspective today. And thank you to our audience for joining us.